My name is Alex Galt. I'm a teacher at Edina High School, and today's lesson is about finding domain, range, and end behavior using interval notation to describe a function's domain and range. If we want to describe a function's domain or range, the domain of a function is going to be all of the possible inputs for the function, or the x-coordinates. The range of a function would be all of the possible y-coordinates, or outputs for the function. These two words, if you put them in alphabetical order, and you put x and y in alphabetical order, they line up. That's kind of how I remember which is which. So the domain are going to be the inputs, and the range will be the possible outputs. For the domain of a function, we want to look at all of the values of x that make sense for the function. This particular function kind of goes off the graph. I want you to imagine that it continues in the behavior that you see after it leaves the grid that you see. So for domain, what I do is I look at the furthest left-hand point first, and this point on the graph is the farthest left that I see. But this point also continues kind of sideways, mostly up, but a little bit sideways. And so this domain is going to continue off the graph, going further and further out to the left. So what I say for that is I say that the domain goes all the way to the left to negative infinity. And then I go to the furthest right-hand point, and I say, well, that furthest right-hand point is also arrowing off to the side. It's mostly going up, but it's also going to the side. And so my biggest x-coordinate would be positive infinity. And in inequality, I write negative infinity is less than x is less than infinity. Or another way of reading that is x is between negative infinity and infinity. Inequality notation is okay, but I actually prefer interval notation just because it takes fewer characters, and it's also kind of what we use in calculus class. Interval notation, we would do negative infinity first because that's the small number, and then we would do positive infinity second because that's the big number. It's not really a number, but it's the big value. And then because you can never be equal to infinity and you can never be equal to negative infinity, we use parentheses for that. Another way of thinking about domain is think about your furthest left-hand point. Bring it down to the axis. Bring it down to the x-axis. Think about your furthest right-hand point. Bring it down to the axis. And then it has an arrow on it, so you put an arrow on it. And this has an arrow on it, so you put an arrow on it. And notice that everything in between there is also included. And so just looking at the number line for that domain, in the x direction, this function can take on any value between negative infinity and positive infinity. It's anything on the x-axis works. Okay, for the range, I'm going to use a different color. For the range, when I put my pencil on the lowest point, it does not have an arrow on it. So the lowest point for this graph is -1. And when I put my pencil on the highest point, there's kind of a tie, but the highest point, regardless, has an arrow on it. So the graph is going to start at -1, but it then continues up forever in that direction for positive infinity. So my inequality is going to be -1, but we're going to say less than or equal to, and we're going to say y because range is the y-coordinates, and then we're going to say less than infinity. So because the graph does have a point, it has an actual point with a y-coordinate of -1, we can be equal to -1, so we put an equal to sign on that inequality. In interval notation, we always put the small number first, but in order to show that it can be equal to -1, we use a bracket. So we say -1 to infinity using interval notation. We always use less than signs and parentheses with infinities because you can never really be equal to infinity. All right. And then for end behavior, what we do is we look at, as our x-coordinates get bigger and bigger, so as our x-coordinates go towards infinity, and this arrow just means go towards infinity, so as our x-coordinates get bigger and bigger, what happens to our y-coordinates? So as I plot a bigger and bigger x-coordinate, notice how it's going to go up and up, like so this graph, as I get bigger and bigger x-coordinates, I would plot it on the graph higher and higher. So my graph goes higher and higher as my x-coordinates get bigger. So my end behavior, my y-coordinates, are also going to go towards infinity. As x goes to negative infinity, so as x goes this way, my y-coordinates are also getting bigger and bigger because the graph would go higher and higher as my x-coordinates get bigger and bigger. So my end behavior as my x-coordinates go towards negative infinity, my y-coordinates are going to go towards positive infinity. Okay, takes a little bit of practice, but it's an important concept, so it's worth working at. Sometimes we don't let x be anything it wants to be. Sometimes we do what's called restricting the domain. So we have a piece of a function. And for this piece of a function, I'm going to start by thinking about the x-coordinates. So I put my pencil on the furthest left-hand point, and I go down to the x-axis, and I say, well, I'm going to put an open circle there. What it means when we graph with an open circle is that we can't be that value, but we can be very, very close to that value. So I'm going to put an open circle there. And then I put my pencil on the furthest right-hand point, and I say, oh, well, the furthest right-hand point is at 4. And so on this graph, it's all the values between those 2 points. And then for an inequality, I would say it's going to be -2, and it isn't equal to -2. It's all the way up to -2, but not equal to -2. And then I say less than or equal to 4, because this value 4 is on the graph. In interval notation, I would write that as my small value first with parentheses because it's not equal to that value, and then my large value second, and that one has a bracket because it is equal to 4. And then for range, I'm going to use a different color. So for range, I go to my lowest point on my graph, and I say, well, my lowest point has a y-coordinate of -2. I go to my highest point on the graph. My highest point has a y-coordinate of 5. So my range is going to be between +2. My range is going to be between 2 and 5. And the 2 is not included because that point, the lowest point, was an open circle. But the 5 is included because that point has a closed circle. In interval notation, that would be 2 with a parentheses and 5 with a bracket. For this particular function, there's no end behavior because I don't have x going to infinity. X just stops at 4, and I don't have x going to negative infinity. It stops at -2. Here's another example where the graph goes, the function goes off the graph. So remember, we can think about it as continuing in the way that it appears to be going. For the domain, we look at the furthest left-hand point, and this point, the furthest left-hand point, looks like it's going off towards negative infinity. So it's going sideways. So our domain is going to be negative, in inequality notation, I have that backwards. So I'm going to do negative infinity is less than x, and then I put my pencil on my furthest right-hand point, and this is really going up, but it's going a little bit sideways as well. So my inequality is going to be from negative infinity to infinity, and my interval notation would be negative infinity to infinity. Both of these 2 points, my furthest left-hand point has an arrow on it going sideways, and my furthest right-hand point also has an arrow on it. The range is a little bit different. This particular function is getting closer and closer to the x-axis, but it doesn't look like it's getting any lower. It's getting really, really close to the x-axis, but it's not going below it. And I think no matter how far out I went, this function would just get closer and closer and closer to the x-axis, but it would never cross the x-axis. So actually, the range is kind of different for this one. There is no value that gives me a y-coordinate of 0, but it gets very close to 0 as my lowest value. And then my highest value, it's shooting way up towards infinity. So for the inequality, we're going from 0 to infinity. In interval notation, that would be 0, but not including 0 to infinity. There's no real value there's no real x-coordinate that gives me a value of my function of 0. My end behavior, as x goes to infinity, so as my x-coordinates get bigger and bigger this way, my y-coordinates are shooting up towards positive infinity. So my y-coordinates are getting very, very large. As x goes to negative infinity, so if I go this way on my graph, the behavior of my y-coordinates are getting closer and closer to 0. Okay? So that's kind of different end behavior for that graph. This one is asking us to make a graph ourselves, and so it's a good reminder about linear functions. So if I'm going to make this graph, remember y equals mx plus b from your past, and m is your slope and b is your y-intercept. So this graph is going to have a y-intercept of 2. So on my y-axis, I'm going to go to 2 and make a point there. And then I'm going to have a slope of negative 1/2. So my slope is going to be negative 1/2. And so that means that from this point, I'm going to go down 1, right 2. And then I'm also going to go up 1, left 2 if I wanted to do more points. What I notice about the domain that I have here is that I need to go all the way up to 2, but I don't need to include 2. So I'm going to put an open circle at 2. But then I need to keep going until I get to negative 6. So that means that I'm going to continue those steps until I get to negative 6. And I will include negative 6 because that one is an inequality with an equal sign on it. So I'm going to draw that line all the way up to that open circle. The range of this function, if I put my pencil on the lowest point is at 1, but the 1 is not included. So I have the lowest point is at y equals 1. The highest point is at y equals 5, and then I have all the points in between. So and y equals 5 is filled in. So my inequality, or my interval notation, would be from 1 to 5, and including the 5. Okay. This example says that my domain is going to be from negative infinity to 3, and my y-intercept is going to be negative 1. And then from there, I'm going to go up 2 over 3. So this is included, but that's the end of my graph. And then my x-coordinates get smaller and smaller, so down to left 3. And so it's going to look something like this, where it keeps going. The range for this function, the lowest point has an arrow on it, so it's continuing down. So the lowest point is going to be down to negative infinity. The highest point has a circle on it. So the range is going to be from negative infinity to 1. Remember, you always start with the lowest point and end with the highest point. The end behavior, there's no end behavior as x goes to positive infinity because x stops at 3. But as x goes to negative infinity, my graph is getting lower and lower. The y-coordinate behavior is that they're getting smaller and smaller, so f of x goes to negative infinity. Okay, the last example asks you to use your calculator to sketch a graph of f of x equals x minus 2 squared. I'm going to show you how to use your calculator so that in case you haven't done that before. So I'm going to encourage you to stay away from the scratch pad grapher and to get used to using documents. So we'll open a new document. No, we don't want to save the old document. And then we're going to add a graph. And we're going to type in x minus 2. And then the way we get the exponent is with this little caret button. And then we type squared. And when you hit enter, your graph shows up. The domain of this graph is going to be all the numbers from negative infinity to positive infinity because we know that it goes off the screen, but the x-coordinates could get small as they want to or as large as they want to. And then the range of this graph will be from 0 to infinity because the lowest y-coordinate is 0 and the graph keeps going up.